further topic. Electric field. See, field means space. So if this is one charge, there is some space surrounding it in all directions. That means actually it is spherical region. Up to certain distance, it has its space. Where you bring another charge, it will experience force. It will experience force. That means the space surrounding charge, in which when unit positive charge placed experiences force. Unit positive charge is also called as test charge. That means it will not affect the field of existing charge. इतना छोटा है वो, उसको test charge बोलते हैं. छोटे से छोटा charge means due to losing one electron. Therefore, it is called unit positive charge. The space surrounding charge within which, मतलब जिसका अंदर, within which unit positive, within which unit positive charge placed experiences force is called as electric field. The space surrounding charge within which unit positive charge placed experiences force is called as electric field. Right definition of electric field?
Done, sir.
Done, sir.
Okay, wait. Now, if this is space surrounding charge, we said unit charge placed will experience force. Will experience force. अब ये force कितना strength वाला रहेगा? That is mathematically measured by quantity called electric field intensity. So sometimes they will just write electric field is 345. That means actually it is electric field intensity. Suppose ये फर्स्ट वाले को चेक करने का इसके पास कितना ताकत है, तो इसको फोर्स देना पड़ेगा किसको? तो इसने सेकंड वाले को फोर्स दिया, सेकंड वाला चुपचाप बैठ गया, मतलब इसका ताकत ज्यादा है। सेकंड वाले ने इसको बजा दिया, तो उसको समझ गया नहीं अपना औकात कितना है। सो इफ आई वांट इंटेंसिटी ऑफ फर्स्ट चार्ज, I will apply force on the second charge. If I want intensity of second charge, we should apply force on the first charge. So this force acting per unit charge is called as intensity of that charge. मतलब ये suppose field है कैपिटल Q का, इसका अंदर स्मॉल q आया, तो मुझे q का इंटेंसिटी ढूंढने का है, तो I will apply force on small q. Okay, clear meaning?
Yes, sir.
So
yes, sir.
Yeah, the force acting per unit charge. The force acting per unit charge is called as electric field intensity. Just write definition, then formula and its direction we'll see.
Done, sir.
Okay. It is given by E bar equals to F bar upon Q. It is a vector quantity directed outwards for positive charge and inwards for negative charge. It is directed outward for positive charge and inward for negative charge. That means if this is the charge positive, then field will be outward. If negative, then it is inward. This is meaning of directed outward or inward. Its SI unit is force is Newton, charge is Coulomb, so Newton per Coulomb. Its dimension is, anybody can tell what will be its dimension? Newton means M1, L1, T minus 2 because it is force. Coulomb means charge, charge is IT, so A1, T1. So I can say M1 L1 T minus 3 A minus 1. Okay,
Yes, sir.
write this much.
Done, sir.
So everybody now understood what is intensity of the field. It is force acting per unit charge. Direction is outward for positive, inward for negative. And dimension we got M1, L1, T minus 3, A minus 1. Derive expression. Derive expression for electric field intensity due to point charge. Derive expression for electric field intensity due to point charge. Suppose this is charge Q at A, at point B, we want what is intensity, which is a distance R. So if I consider a test charge here Q naught, दोनों का बीच में force होएगा repulsive directed outward. This force acting on Q1 will give me intensity of Q. So I'm writing like this. Consider a point charge. Very simple derivation. Consider a point charge Q situated at distance small r in air from test charge Q naught at B. Therefore, by Coulomb's law, force of repulsion, comma F equals to 1 upon 4 pi epsilon Q naught upon r square. Therefore, electric field intensity E equals to force upon charge Q naught. So I can say E equals to 1 upon 4 pi epsilon naught Q naught upon R square divided by Q naught. This Q naught you can cancel. So we get E equals to 1 upon 4 pi epsilon naught Q by R square. Clear? This is the expression for electric field intensity. So first I thought of two charge because force के लिए दो charge चाहिए. By Coulomb's law, this is force. Q का intensity मतलब force on Q naught. Therefore, we got required answer. Clear? Hello?
Yes, sir.
Yes, yes. Please do. हेलो हाँ मैडम हाँ नहीं 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 चलेगा मैं इवनिंग में ले लूंगा 7:30 हाँ 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 यस 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 ठीक ठीक है
Done, sir.
Okay, everybody is done.
Yes, sir.
Okay, I'm going further. In vector form, if they ask write it in vector form, then E bar will be 1 upon 4 pi epsilon naught Q upon R square into R cap. R cap is unit vector along the direction of the field. So we can write in vector form. If charges are situated in medium other than air, medium other than air, having dielectric constant K, having dielectric constant K, then E will become 1 upon 4 pi K epsilon naught Q by R square. Now write this much. Then we'll see its graph. Done?
Done, sir.
Graph of E versus R. Graph of E versus R. Since E is 1 upon 4 pi epsilon naught Q upon R square. So we can see that E is inversely proportional to R square. Therefore, graph of E against R will be inverse. Please write this and then draw the graph of E against R.
Done, sir.
Graph is a curve. See, there are two types of field. One is called uniform electric field, other is non-uniform. Now suppose this is point charge. At this distance, if E has magnitude, let us take 10. Example बोल रहा हूँ 10 इधर P पे. So to represent 10, I am using this arrow. at this distance it will become less or more? ज्यादा डिस्टेंस किया तो
लेस
लेस हो जाएगा। तो इसको
Less.
हाँ, तो इसको थोड़ा कम एरो से बताते हैं, बट जनरली वी डोंट पुट एरो 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 एरो, पहले बड़ा फिर थोड़ा छोटा फिर थोड़ा, ऐसे सिंगल एरो बना देते हैं। ये एरो इंडिकेट्स डायरेक्शन, एंड ऐसा डाइवर्जिंग होगा ज्यादा तो फील्ड इज वीक। दिस इज मेथड। नाउ सी, यूनिफॉर्म electric field. Meaning of uniform. If field is uniform, that means its magnitude and direction is same throughout. That is called uniform. A uniform field is that field whose magnitude and direction. Uniform electric field or field is that field whose magnitude and direction is same at all points. So when magnitude and direction of the field remain same at any point is called as uniform field. Example C, uniform field का. This is suppose one plate given positive charge. This is another plate given negative charge. अभी दोनों के बीच में फील्ड होएगा going from positive to negative. This is uniform field. हर जगह पे magnitude same, direction same. They are always represented with equal spacing in between. मतलब ये spacing अलग अलग नहीं करना, ऐसा 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 नहीं चाहिए, एक सरी का यूनिफॉर्म. This is our uniform field. This is that. So field which has same magnitude, same direction at all point is called uniform field. They are represented by equispaced parallel line. आप देखो कैसा भी ऐसा भी कर सकते हैं, but equispaced parallel line. ऐसा भी कर सकते हैं, but equispaced parallel line. Clear what is uniform electric field?
Yes, sir.
Write the definition and draw that diagram in example.
Done, sir.
Okay. Second, non-uniform field. Uniform means magnitude, direction are same at every point. Now, non-uniform means may not be same. A field whose magnitude, and direction is not the same. The field whose magnitude and direction is not same at all the points is called as non-uniform field. Example, if we consider point charge Q, then it will have field in all direction, radially outward. Now, all the fields are in same direction or different direction?
Different.
Different.
That means this is non-uniform field. Even though magnitude is same but direction is different, then it is called non-uniform. If both are same, then uniform. So write non-uniform, draw the diagram. Sometimes they can ask you, field due to point charge is uniform or non-uniform? Non-uniform. Field between two plate of charge conductor, uniform. This way they can ask you in MCQ question. Right, second one, draw the diagram.
Done, sir.
Show that E means electric field is potential upon distance between two plates. Show that E equals to V by D. If we consider a uniform electric field between the parallel plates, if E is the value of electric field, we are moving charge Q in this plate, between this plate. So consider charge plus Q between the plates having electric field intensity E directed from positive to negative charge. So this charge will experience force. Hello?
Yes, sir.
What is force formula? Force upon charge is intensity. So charge will experience force QE if D is distance between the plate, then work done to move the charge from positive to negative is force into displacement. Force is constant, therefore no need of integration. So work is QE into displacement. Work done to move the charge is E into D. What is work done to move the charge called as? Potential difference between 2 points. So it is V equals to E into D. Therefore, E equals to V by D. Thus, electric field intensity is also defined as potential difference upon distance. What will be then its SI unit as per this formula? एक हम लोग को मिला न्यूटन अपॉन कूलम, इसका वजह से क्या मिलेगा? वोल्ट अपॉन मीटर. So electric field intensity has two unit, Newton per coulomb or volt per meter. Again I am repeating this sum. Consider uniform electric field E acting between two parallel plates having positive and negative charge. Please copy only this much first. Draw the diagram. In this, show one charge. Consider uniform electric field E acting between two parallel plates having positive and negative charge.
Done, sir.
When charge Q is moved from negative plate to पॉजिटिव प्लेट. देखो उल्टा लिखा है, नेगेटिव प्लेट टू पॉजिटिव प्लेट. Then work is done against force. This work done against force becomes potential. Then work is done against the force, or you can say against the field. Then work done against the field be W. Therefore, W equals to FD. F is nothing but QE into D. Work upon Q equals to ED. Work done to move charge against field is called as potential difference in bracket V. Therefore, V equals to E into D. So, E equals to V upon D. Now, copy till end.
Done, sir.
One more line. Thus, SI unit of electric field Thus, SI unit of electric field. Thus, SI unit of electric field is also volt per meter. संतोष अभी आंसर की भेजा देखो लास्ट संडे वाले टेस्ट में, वो पूरा अच्छे से कर दो, वो पूरा कर दो, फिर मैं आपको वो मुझे वापस रीच भेजो, फिर मैं चेक करता हूँ, परफेक्ट कर दो, फिर मैं आपको पेपर देता हूँ। हाँ अभी देखो आपके पास करंट इलेक्ट्रिसिटी का आंसर नहीं है ना, जो दिया है आपने मुझे 11th के लिए, तो मैं उसका भी आंसर आपको आज दे दूंगा, पूरा रख देना चेक करके बराबर। Yes, 1 minute, huh? 1. See, I'm not doing numerical. At the end, I will start with numerical and MCQ. First, I'm completing full theory. Right. Electric dipole. What is meaning of di? 2. Pole means end. So suppose we have negative charge and positive charge separated by distance 2L. This type of configuration, which has equal and opposite charge separated by finite distance, is called as electric dipole. See, so far we are doing point charge, single charge. अभी दो equal opposite आ गया. So 2 equal and opposite charges. 2 equal and opposite charges separated by finite distance is called as electric dipole. Two equal and opposite charges separated by finite distance is called as electric dipole. It is as shown below. A diagram. Any doubt in what is electric dipole?
No, sir.
सिंपल है, खाली याद रखना है, इक्वल ऑपोजिट चार्ज, लेफ्ट में मैंने नेगेटिव दिखाया, राइट में पॉजिटिव, आप कैसा भी दिखा सकते हो, और दोनों के बीच में फाइनाइट डिस्टेंस. राइट दिस डेफिनेशन. Next lecture this chapter will get completed. That is on Tuesday we'll be able to complete this chapter completely. Not completely, at least theory and numerical. Then one lecture for MCQ.
Done, sir.
Wait, sir.
Done?
Wait, sir.
Okay, waiting.
Done, sir.
electric dipole moment. See, whenever moment comes, that means it is related to torque. So if something can move, we say it is moment. The product of a charge, the product of magnitude, the product of magnitude of a charge forming electric dipole and finite distance between them. The product of magnitude of a charge and finite distance between them is called as electric dipole moment. It is given by P equals to, denoted by P equals to Q into 2. Just copy this, then we'll see whether it is vector or scalar, SI unit, dimension. The product of magnitude of a charge forming electric dipole and finite distance between them is called as electric dipole moment.
Done, sir.
This is negative charge. This is positive charge. That P is directed from here to here. That means negative to positive. So because it has direction, we say it is vector quantity. It is a vector quantity. हेलो, वो पेपर में जो दिया है सम नंबर था, जरा डायग्राम देख लिया करो ना, मिक्स हो गया, दिख नहीं रहा डायग्राम. 37 वाला। हाँ, हर बार मेरे पास टाइम नहीं रहेगा, वो आप एक पेपर भेजोगे, मैं देखूंगा, फिर आपको 10 बार बोलूंगा। खुद से देख लेने का ना कि पेपर मिक्स हो रहा है कि क्या हो रहा है, उतना तो कर सकते हो। 2 डायग्राम मिक्स हो गया, दिखेगा नहीं ना बच्चे को। अभी बार बार मेरे पास टाइम नहीं होने वाला है। 10 पेपर है, 10 पेपर को मैं क्रॉस चेक कैसे करूंगा? ऑलरेडी पेपर है अपने, उसको तो अच्छे से देखो। अभी फिर से मुझे देखना ही पड़ेगा ना, अभी कैसे गारंटी करूं कर दिया बराबर है कि नहीं? मतलब आप फिर भेजोगे एक बार, आज दिन में कम से कम चौथा बार ये पेपर भेज रहे हो। भेजो वापस, अभी क्या करूंगा? एक बार में लगता है ठीक से काम करने का आदत नहीं, या तो कसम खा लिया, नहीं मिस्टेक ही करूंगा। हेलो, या इट इज अ वेक्टर क्वांटिटी। वेरी इंपॉर्टेंट है डायरेक्शन वाला पार्ट। डायरेक्टेड फ्रॉम नेगेटिव चार्ज टू positive charge. Directed from negative charge to positive charge. Its SI unit is, charge is coulomb and distance is meter, so coulomb meter. Don't mistake this as centimeter, it is coulomb meter. What will be its dimension then? Can you say dimension? No mass, m0, coulomb is a1 t1, and length is l1, so m1 l1 tm0 l1 t1 a1. Clear? Hello?
Yes, sir.
Yes, sir.
This is the dimension of electric dipole moment. See, terminology is new, but once you understand, it is not that very difficult. ये चैप्टर और ग्रेविटेशन में थोड़ा सिमिलरिटी लगेगा आपको। कॉपी करो। MCQs can be tricky because direction is there, and if direction comes, then when you have to add two things, it is vector addition. Yes, done now?
Yes, sir.
Next heading, right? Axis of electric dipole. Axis of electric dipole. This is negative charge on left side, positive charge on right side. A line passing through negative charge and positive charge is called as axis of electric dipole. This line which is passing from negative charge and positive charge is called as axis of electric dipole. A line joining negative and positive charge of electric dipole. A line joining negative and positive charge of electric dipole is called as axis of electric dipole. Right. A line joining negative and positive charge of electric dipole is called as axis of electric dipole. Okay, done?
Yes, sir.
Right. Equator of electric dipole. Equator of electric dipole. Now this is negative charge. This is positive charge. This imaginary line is called axis. A line passing through center of electric dipole and perpendicular to the axis is called as equator. A line passing through center, a line passing through center and perpendicular to the axis of electric dipole is called as equator of electric dipole. A line passing through center and perpendicular to the axis is called as equator of electric dipole. Right. संतोष, वो 37 का जो डायग्राम है ना, उसमें देखो नीचे लाइन लाइट है, एकदम दिख नहीं रहे हो। 37 जो डायग्राम सेपरेट किया गया उसका, उसको जूम करेंगे देखो एकदम लाइन दिख ही नहीं रहा है ना नीचे। अरे क्या बराबर है, ऊपर का सब लाइन काला है, नीचे वाला सीधा लाइन वो दिख ही नहीं रहा है ना। दिख रहा है क्या आपको? मेरे को तो नहीं दिख रहा है। अरे हॉरिजॉन्टल मतलब मालूम है पहला किसको बोलते हैं? सीधा लाइन होता है ना, सीधा लाइन एकदम नीचे दिख रहा है क्या? नहीं दिख रहा है ना नीचे, खाली ऐसा लग रहा है खुला है ना। अरे समझा क्या मीनिंग, क्या बोल रहा हूँ कि डायग्राम बना के भेजेंगे। हाँ, जो अभी सेपरेट किया ना आपने, उसका ही बात कर रहा हूँ। ऐसा दिख रहा है मेरे को, तो नहीं दिखा पेपर में। आपको कौन सा लाइन समझ रहा है क्या, मैं बता रहा हूँ कौन सा लाइन नीचे जो रहता है ना, हॉरिजॉन्टल लाइन। हॉरिजॉन्टल का मतलब समझता है, वो किधर दिख रहा है? नहीं दिख रहा है ना? क्या दिख रहा है आपको? मेरे को नहीं दिख रहा है, उसको पूरा ज्वाइन करो। बच्चे लोगों को कैसा दिखेगा उसका जरा भेजेंगे तो, जब मुझे नहीं दिख रहा है तो। हॉरिजॉन्टल लाइन का पहला मीनिंग मालूम है? नहीं तो मैं डायग्राम बना के भेजता हूँ, पहले आपको मीनिंग समझने दो, नहीं तो कुछ भी लाइन आपको लग रहा होगा वो। अरे यार 37 का ही बोल रहा हूँ, नीचे से खुला दिख रहा है सब, एकदम लाइट दिख रहा है वो, एकदम लाइट, उसको डार्क करो। अब भेजो अभी डायग्राम वापस, या खाली वो पेज भेजो। Yes, hello, you are done?
Yes, sir.
Okay. So we got electric dipole moment, axis, equator. Now one important derivation. There are in fact 3 derivations now, which are very important for MCQs. Derive expression for torque acting on electric dipole. See, suppose this is positive charge Q and this is field. Then force acting on this will be in the direction of field if it is positive charge. And if it is negative charge, then force ka direction will be ulta of field. Just remember this. Why? Because field is from plus to minus. So if charge is positive, this minus will attract. ऐसा होगा. But if field is this way, positive to negative, and charge is negative, तो ये वाला attract करेगा ना उसको ऐसा. Hello?
Yes, sir.
So for positive charge, always direction of field force will be in the direction of field, and for negative it will be opposite. I want torque acting on electric dipole. So if we have two equal and opposite forces, then torque is nothing but moment of couple, which is any one force into perpendicular distance between two force, that is called torque due to couple. Couple means equal opposite force. So keeping all these basics in my mind, I'm starting with the expression for torque acting on electric dipole when placed in electric field. See this diagram. Say some books will draw electric field upward, some will draw horizontal, all are same, no mistake, because we can place charge anywhere. So this is uniform electric field E bar. In this we are placing one electric dipole. I am placing electric dipole here. We are placing electric dipole. If it is electric dipole means it will have negative charge, it will have positive charge.
Yes, sir.
Suppose distance between them is 2L. Now can you tell me what will be the direction of force acting on positive charge Q in the direction of field? So can I say it is QE acting in the direction of field, and this QE acting opposite to the field? This much clear?
Yes, sir.
Just draw only this first. And this angle with the, this is line joining, imaginary if you draw, it becomes axis, it is making angle theta with the field. Draw this diagram this much. This is field I have drawn. Here electric dipole, this angle is theta, ये पॉजिटिव फोर्स, नेगेटिव फोर्स, ऐसे. Minimum 3 lines you have to draw. I have drawn around 6. If you draw, please tell, because further also we have to draw few things more.
Done, sir.
Done this much? Okay. Now this is QE, this is QE. Can you tell me what will be this angle? This is theta. So what is this angle? Theta only?
Theta.
Theta.
Alternate. हाँ. अब ये side is 12. This is theta. What will be this side? Theta का सामने वाला. Can I say 12 sin theta?
Yes, sir.
So this is 12 sin theta. And बाजू वाला, can I say 12 cos theta?
Yes, sir.
Yes. Now diagram is complete. Please complete this much, then I'm doing clear. Yes, I think you have completed. Now I can start with the theory, correct?
Yes, sir.
Consider हेलो, अरे अब तो क्या बोलो यार, हम लोग बच्चे को यही भेजने वाले हैं ना, तो उसको दिखना चाहिए क्या नहीं दिखना चाहिए, ये बताओ मुझे सिंपल भाषा में। अभी वो देखना पड़ेगा फिर से, अभी आपको कितनी बार समझा रहा हूँ, नहीं समझ रहे तो क्या कर सकता हूँ, इससे डायग्राम बना के भेजा। अरे मेरी बात सुनो, आपने क्या किया बराबर था, अपने को उससे मतलब नहीं है ना, स्टूडेंट को जो पहुंचेगा वो कैसा दिखेगा उससे मतलब है ना। ये मैं भी समझता हूँ, आप भी समझते हो, फिर भी वही चीज पे आर्ग्यूमेंट कर रहे हो, पहले बराबर था अब ये था। ठीक है, consider an electric dipole consisting of equal and opposite charges of magnitude q separated by distance to L to be placed in an electric field of intensity E at separated to be placed in electric field of intensity E with its axis making angle theta with E. The forces acting at two charges are QE. It is directed as shown. So for positive charge, it is shown upward. That means in the direction of field. Negative, it is shown downward, opposite to the field. Copy this much theory. Consider an electric dipole consisting of equal and opposite charges of magnitude q separated by distance 2l to be placed in electric field of intensity E with axis making angle theta with E. The force acting at the two charges are QE. It is directed as shown. This much copy, please. हाँ तो है ना टाइम, उससे क्यों परेशान हो रहे हो, आपको बोला ना आएगा बच्चा लेके जाएगा 10:30 to 3:30। अबे आपको क्या समझाऊं यार, कि आपको उनका काम नहीं करने, मैं बताऊंगा ना क्या काम करने का, अपना ही काम है वो। हाँ वो पूरा नीट का बच्चा अपन कॉमन है मेरा उनका। completed.
Done, sir.
Is directed as shown. Just 5 meters. These equal and opposite charges forms couple and produces torque given by tau equals to any one force into perpendicular distance between two forces. So tau is any one force means QE and perpendicular distance is 12 sine theta. This was upward, downward force. This is called perpendicular distance. But I can say Q into 12 is denoted by P, which is called as electric dipole moment. So torque is P E sine theta. So torque becomes P E sine theta. This is expression for torque. What is AB sine theta in vector you have studied? AB sine theta?
Cross product.
Correct. So this is expression for torque on electric dipole. Torque on electric dipole. In vector form, tau bar equals to P bar cross E bar. Okay. A bar cross B bar means I can write P bar cross E bar. Followed?
Yes, sir.
So this completes our expression for torque acting on electric dipole. Magnitude wise it is P sine theta and in vector form P bar cross E bar. If it rotates the dipole in clockwise, torque is negative, anti-clockwise positive, same as vector. Everybody has followed, it seems, this derivation now.
Yes, sir.
Any doubt? Anybody is having doubt? Mrunmay? Janvi? Chavi?
No, sir.
No doubt? Okay, please
No,
copy till end. This was actually easy derivation based on law of motion chapter ka couple wala formula. Arey. So if I send recorded lecture, you'll be able to go through it. Please go because no, that chapter is not that easy, no? But that day also you had told the same thing to Vishal sir. Yeah, I have spoken to Samir sir. That's what. Is it excuses you are making or it is genuine? No, dear. See, no. See, if you are doing repeat, I know that you have self motivation. That's why you repeat. Otherwise, who will repeat? So, as if 99% try to attend the class. If not, yes, I will send the recorded lecture. But I wish that if you are present, it will be better every time. But if it is unavoidable, then go through that before you come in the next class because everything is linked. Na? ठीक है ठीक है ठीक है use your own wisdom and as for that I yes okay no problem thank you hello okay completed dears.
Yes, sir.
Yes, sir.
So that's all for today. Next lecture 100% entire theory will get over, that is on Tuesday. So test I will keep on theoretical part and few numerical on Friday if it is my turn, and then on Saturday we'll do MCQs. So coming week most probably we should complete electrostatic of 11th standard. If this gets over, I will start with magnetism, very simple chapter. And after magnetism, I will come to light chapter. Once light gets over, then there are two small chapters in part 2, electromagnetic wave and semiconductor. That will hardly take two lectures to be completed. So by Feb end, our topic should get over of 11. Entire March, I will do revision of MCQ of 11th only. April 1 onwards, I will start 12th standard. So that's all for today. Enjoy your day, but safely. Whenever you are going out, please wear the mask till the vaccine is in